Hi geographers, and welcome to the latest video on wave-cut platform formations for the coast topic. I'll let you write the title and complete the do now, so please pause the video to do that for me now. Thank you. Right, so let's go through the answers. We've got question 1, what type of wave has a stronger backwash? And the answer is destructive waves. What type of weathering is freeze-thaw? The answer is mechanical. Does abrasion or attrition involve sediment colliding? The answer is attrition. The force of water is hydraulic action. Headlands and bays form along a discordant coastline. At a discordant coastline, the soft rock is eroded away faster, and when the soft rock is eroded, this forms a bay. So please mark your answers for me. Perfect. Thank you. So today we're looking at landforms of erosion again, and we're looking at a wave-cut platform. Here on the board is a picture of Kimmeridge, Dorset, which shows you a wave-cut platform. This area here, this rocky area, is a wave-cut platform. And this is a cliff of a headland. Okay, and what happened originally is the cliff was located at this point here. The cliff used to be there, and over time what's happened is the sea has eroded the cliff away, so the cliff has retreated inland, leaving behind this rocky wave-cut platform. So all a wave-cut platform is a rocky area at the base of a cliff, because it's really uneven, and it's also only visible at low tide. So the next slide, what we've got here is wave-cut platform Kimmeridge in Dorset. Again you can see the rocky nature and the uneven nature of the surface, but what we need to do is write down wave-cut platform Kimmeridge and just copy down the characteristics of what a wave-cut platform is like. So you'd have, first thing to write down, it slopes gently out to sea. It's got an overall uneven appearance of bare rock interspersed with rock pools, and it's covered at high tide and exposed at low tides. You just jot them down for me, pause it if you need to. Right, so we're going to look at a wave-cut platform diagram. Please feel free to copy this down as I go through it. So the first step you're going to draw, and you're just going to draw a cliff. You're going to label on at the bottom of your cliff high tide. That is as high as the sea can go. And what's going to happen is it's worth labelling that destructive waves are going to erode the base of the cliff. So again, I'll read that again. It says destructive waves erode the base of the cliff. And then go on to your second diagram I'll draw beneath this. Okay. The second step is, if we look at my cliff now, the base of the cliff has been eroded, sort of indented, hasn't it? And this is called a wave-cut notch. So the erosion has created a wave-cut notch. So remember, this erosion has been carried out by destructive waves, and this has been through hydraulic action. So the power of the water hitting the base of the cliff has eroded it away and created a wave-cut notch. And what this now means is the cliff above the wave-cut notch, so here, this cliff is unsupported. So what's going to happen is gravity is going to take place, and the cliff that's here is unsupported, it's going to collapse down like such. So let's have a look at the final diagram. We've got our cliff, and at the base of it I've now got a wave-cut platform because it's really uneven. And the sea. I'll give that, so there we go. So what we can see has happened here is this dotted line shows us the old position of the cliff. The cliff used to be here. The cliff has retreated inland, and that's because what's happened is the base of the cliff's eroded through hydraulic action, creating a wave-cut notch. So the top of the cliff is unsupported, it collapses. And as the cliff collapses, it retreats inland. And what this leaves behind is a rocky wave-cut platform. We can see here that the rocks have fallen off the cliff, and as the rocks fall off the cliff, they smash into this wave-cut platform. And that process of the rocks smashing into it, that abrasion, erodes the wave-cut platform, making it very uneven, so we get little rock pools and little bits of harder rock sticking up. Okay. Here's a diagram showing you the cliff, the wave cut notch. So the base of the cliff is eroded at high tide through destructive waves, through hydraulic action, which is the power of the water eroding the cliff, creating our wave cut notch. This means the top of the cliff is unsupported, so it will collapse. As this happens, these processes will repeat and the cliff retreats inland, leaving behind a rocky wave cut platform. This wave cut platform is rocky and uneven due to abrasion. This is where the rock from the cliff has fallen to the wave cut platform and hits into it, eroding it, creating rock pools at different speeds. So, if you're a little bit confused or not sure about this, please do just stop, go back, watch the video again, jot down the diagrams and listen clearly to the explanation. So we've got a quiz. So, what is A? You should have written down A is a wave cut notch. What is B? B is a wave cut platform. And finally, why will the top of the cliff labelled C collapse? And that's because it's not supported underneath and will collapse due to gravity. Got another multiple choice question for you coming up. Which of these phrases in the formation of a wave cut platform is wrong? Is it 1. Waves erode the base of the cliff? 2. Deposition creates a wave cut notch? 3. Erosion takes place between high and low tide? Or 4. Over time the cliff retreats? You should have chosen the answer as 2. The other 3 statements are all correct. Right, so let's go on to the blue zone and see what question you need to work on today. We've got explain the formation of a wave cut platform, 6 marks. To be successful in this question, you need to follow the POS paragraph. You need to give a process. What processes are happening? Hydraulic action, abrasion. You need to outline it. So you need to say what hydraulic action is, what abrasion is. And you need to give your sequence, what happens first, second, third, etc. So, here are some key, well, here is a model paragraph I've done, but mine's not perfect. So let's have a look. A wave cut notch is formed at the base of a cliff between the high and low tide mark by hydraulic action. That is a process. However, I've not said what hydraulic action is. This leaves the cliff unsupported, which will eventually collapse. This creates a wave cut platform that is uneven due to differential erosion caused by abrasion. Process where rocks hit and erode the wave cut platform, which means outline. So I've got my P and O there. The sequence I've got, this leaves the cliff unsupported, which eventually collapses. There's something missing here. I'm missing something here because what I should say is a wave cut notch is formed at the base of the cliff between the high and low tide mark by hydraulic action. This is the power of the water hitting the cliff. This will leave the cliff unsupported, which will eventually collapse due to gravity. This repeats and the cliff retreats. This creates a wave cut platform that is uneven due to differential erosion caused by abrasion, where rocks hit and erode the wave cut platform at different speeds. So what I'd like you to do is have a go at answering the question. Use the keywords in your answer. So please pause the video here, have a go at answering it. Brilliant, well done. What I need to do is just go back to my model answer. Have you improved it enough? Have you given the process, the outline and the sequence? Please mark on your work where you've done so. Thank you for watching. Thank you for taking the time to do this. Have a great day. Speak to you again when you watch the next video.